Hi, my name's Robin. I haven't taken any Lauren's statistics courses. I'm on the other end. I was actually on our search committee, and I still remember that one of the letters said, "Hire her. You will never regret hiring Lauren." And so I am a biologist, and I come at this whole problem from the other end, which was I started working with the data. And then I've never taken a computer course in my life. The one stat course I took, I got a C, which is probably one of the only C's that I got in college. And so you might be putting big X's through me because of that. I like working with the data, and now it would be called, people would call me a domain scientist. And so Lauren knows more about my work. I study RNA structure, and I was very proud to have mostly manually, but using some computer tools, predict this RNA structure at about 98% accuracy. So it's working with the data. So now, over time, I've, of course, learned a lot more about computers. I use the computers all the time. I work with various computer scientists at various different levels. And the one thing that I'm able to do is then to have an oversight and some intuition on if what they're doing is correct or not. And I'm wondering to what extent, as you hire people and you work through lots of data, is there someone or a group of people that are able to sort of like, even though I don't feel like I'm that old, I guess in this audience I'm older than maybe the average or a bit, is someone who's sort of wise and has that ability to perceive if you're going in the right direction, as you now have many, many different parameters, variables, approaches. And so that's sort of a big topic. And then maybe a specific question you could try to answer or address is, I'm wondering if you're able to determine the contribution for the different approaches that you're using. Or to maybe say it in another way, is that you do a self-analysis of your effort itself, and you determine, like doing a big data analysis of your effort, and then come back and, or like a PCA type, and say, this group is actually contributing or this group or this approach is contributing 80% to our success, and this effort is only contributing 5%.
I'll take a first shot at the what I think is sort of the domain side of what you're asking. Several of my first conversations with recruiters, we're actually in the process right now of recruiting a head of our data science function. We've got a team of about 6 folks, and we need some of the kind of wisdom you're describing. And I've had recruiters ask me, so you're looking for an education data scientist, right? Like, well, no, that doesn't exist. No one has done data science in this kind of data before. And so for us, it's the intersection between data, technology, and domain expertise. It's that overlap in the middle that I think can actually start to produce useful insight. The technology in and of itself certainly doesn't contain all the answers, and clearly the data in and of itself doesn't contain the answers, particularly if you are dealing with folks who are quite accomplished in its manipulation and analysis, but don't actually understand how it works, what that data set is saying in some sort of foundational kind of instinctive way. And so for us, we don't necessarily solve that problem with kind of one education data science yogi that's making sure we're moving in the right direction. We have to create communication. We've got a lot of really deep education domain expertise on the team, and we have a lot of really strong, deep analysis expertise on the team, and those sets of expertise do not live in a single individual together. And so we have to find ways to make sure that those checks and balances are happening, and it's actually a constant sort of iterative process for us internally. I love the chess analogy for thinking about this work. Chess obviously is there are a limited set of possible decisions, right? And so we know machines are really great when you give them a well-defined limited set of possible outcomes that they can analyze. And a few decades ago, machines got better than humans head-to-head in playing chess. It is still the case, though, that tactics in chess, sort of five moves out, machines are much better and faster at than human beings are. It's strategy that people are much, much better at than machines. And so the very best chess player is a grandmaster with essentially a smartphone in their hand. That level of computing power is enough with the sort of man-machine symbiosis that comes there to beat any other kind of chess player. And I think that's, from my perspective, part of what domain expertise has to contribute in our world is education, domain expertise in particular. But if you can let the algorithms do what they're good at doing, and let people do what they're good at doing on top of that, I think you have a chance to really accomplish some dramatic things with data. But if you're missing either of those equations, I think you're much less likely to get to where you're trying to go.
Yeah, I have to agree. The cross-functional approach in our world works so well because we've got people that can put together data sets that are just beautiful and they're absolutely meaningless because they don't have the right kind of data, or they can't explain to you what that data really means. So having that wide range of people that are touching the data and working together has been a process that we've finally gotten to where they can communicate with each other and understand what's going on. And from your percentages question, for us it depends on what we're looking at. So for those future modelers, their work will be a huge weight in developing a new program, whereas the person coming in to do the verification has a huge weight when we're trying to sunset a program or end a program to see how well it went.
I'll say that I actually really like both of your questions because it really gets to sort of some foundational things that we've discovered over the years in our business, which is that you really need that domain expertise, and it's not necessarily someone who knows how to trade who can come in and they know how a market works or anything. It's really the experience of wrapping yourself in the data, and for an extended period of time and sort of experimenting and playing and poking and prodding and seeing what happens. I often joke about you need to sort of, roll around in the data and lather up in the data and, dry off and try it again and do this for an extended period of time before you sort of generate those instincts about what might work and what might not work. And, we've got a number of people who've done a lot of that, and it's helpful to sort of get their experience. Although, the downside of that is you often have someone who will say something like, I tried that and it didn't work. And we always have to encourage people to try it again in their own way because, someone who's, a real expert's done a lot of this, if they had one parameter that was a little different or one assumption that was a little different, it may invalidate the entire experiment when the rationale is fundamentally sound. So, yes, the domain knowledge is essential, and I think the only way to get it is through experimentation. The other point real quickly is sort of your question about analyzing your analysis and your process. And that's been also a huge win for us over the years. We could just look at the data and come out with an output and go do it. But what we've also spent a lot of time on at various times, and it can be very computationally expensive to do this, is we actually evaluate all the processes we use. And we, come up with learning which are the processes that produce the best results at the end, which are the processes that are the most resilient to change in different regimes and whatnot. And so going back and, taking a process, rolling it forward, looking at different time windows, that's often been a source of very good insight.
Yeah, it's a very similar answer. I've said that before. In my role of trying to automate what people are doing in their daily analysis jobs and in trying to let the machines find the interesting correlations so that the people don't have to dig through the data, it's a very fine line to walk because if you get people that aren't ever experienced at looking at the data, you don't have anyone that can tell you that the machine did it wrong. And being able to walk that line of still getting people that will dig through the data and understand what it means and can challenge the machine. Right? It's really easy to say, big green button, everything's good, I'm going to go get a coffee. Right? and the our goal, of course, is to be able to have a big green button so that somebody can go get a coffee and go work on some other interesting problem, but we'll get it wrong, right? The models will sometimes be wrong, something will change we didn't expect, and if we don't still have people that understand what the data is and what's going on behind the scenes, then it's really difficult to have somebody be able to challenge the model. So.
That would everything to add?
I think, again, similar answer, very similar perspective around, we definitely look to hire people that are well-rounded, that want to slice and dice into the issues and actually look for the business problems, I think was kind of the core about this. And yeah, I mean, fifth person in line. Yep. Check.
Well, thank you all. So our time together has drawn to a close. I want to thank all of you for coming out, for the excellent questions, for all of you who have been teaching in our Summer Statistics Institute, and especially our SSC staff who've worked so hard to put tonight together and this whole week together. Thank you all very much. And finally, thank you very much to Neville, Charles, Liz, Steve, and Richard, our illustrious panelists. Thank you for sharing your wisdom and your precious time with us. It's been very illuminating, I think, for me, and I hope for all of you. And I encourage you all to go home and lather up in some data. So good night, everybody.